In the last video on chemical formula, we looked at how to write the formula for a chemical for cases where there were clues in the name, and those clues were mono, di, tri, tetra, etc. Then we also looked at the main method, which is using valency. We then looked at compounds with transition metals, where Roman numerals are included in the formula to tell you what the valency is. This video is going to focus on the final two types of formula you need to be able to write. We're going to think about chemicals that end in ite or ate, so I-T-E, A-T-E. And we're also going to look at ionic formula. So firstly, we need to think about compounds that end in I-T-E or A-T-E. Now, if a chemical ends in that, it means it contains oxygen. Contains oxygen. Now, this rule also applies to chemicals with hydroxide and chemicals with ammonium. So this rule applies for compounds that end in ITE or ATE, and chemicals that have hydroxide in the name, and chemicals that have ammonium in the name. So those are the four cases: ite, ate, hydroxide, and ammonium. Now, when it comes to these chemicals, you need to look up page 8 of your data booklet. And I'm going to show you that page here. So I'm going to zoom in. So it's the top of page 8. Let's see if I can make it nicer there. Okay, it's not wonderful, but we can see it. Now here's a list of parts of compounds that have special formula. So they don't just use the symbol for one element, they contain mixtures of elements. So ammonium is one here, and it's NH4, and it's got a plus. Then we've got a lot of ones in this one negative column. We've got hydroxide, we've got nitrate, which are the two most common ones you'll need to use from this one. Then we've got two negative, where the most common one you'll probably be asked is sulfate, SO4, 2 minus, and then we've got 3 negative, PO4, 3 minus. Now we use this table in a very similar way to how we would use valency. All we do when we're writing the symbol for that part of the chemical, if we've got ammonium, what we write are the numbers and letters. We ignore the charge when we're writing the symbol. We ignore the charge. Then the valency is whatever the number written at the top of the column. So for ammonium, NH4 is the symbol and the valency is 1. Nitrate here, what you'd write as the symbol is NO3, ignore the charge, and the valency is 1. Sulfate, SO4, ignore the charge, and the valency is 2. And phosphate here, PO4 is the symbol, ignore the charge, and the valency is 3. So we'll just show two examples of using that. And the first example we'll use is calcium sulfate. Now, it's a chemical that ends in ATE, so we know we need to use page 8. Now, sulfate is in this column, the 2 negative column. And it's got a symbol, VSDF, it's got a symbol of SO4. So a symbol of SO4, and because it was in the column 2 negative, that means it's got a valency of 2. Now this next part, calcium. So calcium is just treated as we would before. So we look up the periodic table, we see that the symbol for calcium is Ca. It's in group 2, so it has a valency of 2. Then what we're going to do is we're going to do the next S, we're going to swap. Then we've got to ask ourselves, can we divide through to make anything more simple? The answer is yes. We can divide each side by 2. And then because we've got one of each, we just write the symbols. So we would write Ca SO4. Now the next example we'll use is aluminium hydroxide. Now, aluminium hydroxide, it doesn't end in ITE or ATE, but it is one of the 2 special cases. So we do have to use that table on page 8. And when we look on page 8, hydroxide is here. It's got a symbol of OH and it's in the column with a title of 1. So the symbol for hydroxide is OH. It's in a column with 1 at the top, so the valency is 1. Aluminium, we use the normal periodic table for it. Its symbol is Al, and it's in group 3, so it's got a valency of 3. We swap. Can we divide through by anything? We can't. And now it comes to writing the formula. So aluminium part, that's easy. Aluminium 1, so we just write the symbol. But hydroxide we've got 3 of. So where do we put the 3 and where do we put this? Well, to make sure that we say that we've got 3 hydroxides, this is where we use brackets. So if the number below something, the symbol that's got more than 1 capital letter in it, is greater than 1, we put brackets around it and then we write the number. So the aluminium, 1, hydroxide, all in brackets, there is 3. So that's how we deal with compounds that end in ate, hydroxide, or ammonium. We just use page 8, and on page 8 we get the formula, we get the symbol that we're going to use, and whatever number is written at the top of the column is the valency. The next one is ionic formula. An ionic formula is slightly different in that what you will be writing is symbols with charges. And whenever I'm doing this, what I do is I change it to S, I, V, S, D, F. And I just stands for ion. So this stands for ion and its symbol, ion valency, swap, divide, formula. The difference between the symbol and the ion is that the ion has the charge as well as the symbol. So the example we're going to start with is we're going to work with sodium oxide. So sodium oxide. The symbol for sodium is Na. The symbol for oxygen is O. Now, depending on what group you're in on the periodic table, you're going to form different charged ions. Now, on the periodic table like this is ignoring the transition metals. Group 1, 2, 3, 4, 5, 6, 7, 8. Valency goes 1, 2, 3, 4, 3, 2, 1. Charge, +1, +2, +3. Group 4 is strange because it's plus or minus 4. Group 5, -3, -2, -1. So charge goes +1, +2, +3, plus or -4. Group 4 is strange, then go -3, -2, -1, and the end ones don't have a charge. So sodium is in group 1, so its charge is going to be +1. So Na plus is our new way of writing it. Oxygen is in group 6, so if we count along, +1, +2, +3, +-4, -3, -2. That's where oxygen is. So it's oxygen, and we write 2, then the minus. Now valencies. Again, sodium's group 1, so it's got a valency of 1. Oxygen is group 6, and it's got a valency of 2. We swap. Can we divide? Not in this case, we cannot. Now when it comes to writing the formula, what we have to do is use our ion as the thing that we put in the formula. And we always put it in brackets. So Na plus in brackets, and the number underneath is a 2, so we put Na2. Then oxygen, O2 minus, in brackets, the number's 1, so we don't need to write anything. So you can see it does look a bit more complicated, but it's Na in brackets, Na plus, in brackets 2, and then O2 minus. We'll do 2 more examples of this. So the next one we'll do is we will do one containing a transition metal. So we will do copper 2, and we will do copper 2 sulfide. And SiBSDF. So the symbol for copper is Cu. The symbol for sulfide is an IDE, so we're just using the periodic table. And it's got a symbol of S. Now when it comes to transition metals, they have these Roman numerals. Whatever number is in the Roman numerals is the valency, but it's also the charge. And it's always, because it's a metal, it's always positive. So we've got a 2 after copper, so the charge on the ion is Cu2+. Sulfur is in group 6, So sulfur's here, charge goes +1, +2, +3, plus or minus 4, -3, -2. So it's got a charge of 2 minus. The valency, again, well, copper, it's got 2 here, so the valency is 2. Sulfur was in group 6, so it's got a valency of 2. We do our swap. Can we divide? In this case, yes, we can divide each side by 2. So when it comes to writing the formula, remember we're using the ion and we put it in brackets. Cu 2 plus, and there's a 1, so we don't need to write anything else. And then we have got sulfur 2 minus. So that's it. The final example is going to be the most difficult one we'll do. And this is going to combine pretty much all the types together. We're going to do ammonium sulfate. Now, it's ammonium and it ends in ATE, so we need to use page 8 of the data booklet to get the symbols and to get the charges. So in this case, if we look and we look really closely, the formula actually tells us the symbol and charge. So that's what we're going to use in both cases. So we can ignore just the symbol and go straight to the ion for ones on this page. So ammonium, NH4 plus, sulfate is here, SO4, 2 minus. So we can ignore just writing the symbols and we can go into the ions. So we don't need to write that. NH4 plus, SO4, 2 minus. Now, on this page, ammonium is here and it's got a valency of 1, that's what's written at the top. Sulfate is here and 2 is what's written at the top. So, sulfate has a valency of 2, ammonium has a valency of 1. We swap. We cannot divide to make it simpler, so we have to write it this way. And then what we do, we take our ion, we put it in brackets, NH4 plus, and we've got a 2 there, and then we've got our second ion, SO4, 2 minus, and there's a number 1, so we don't need to write anything. So that was that. So today, what we covered were the final 2 parts of writing chemical formula. We looked at compounds that end in ITE and ATE, but also hydroxide and ammonium. And then we looked at writing ionic formula. So we know that for this one, we need to use page 8 of the data booklet in order to help us. And when it comes to writing ionic formula, what we do is we add in just this extra I so that we can write the symbol with the charge. So that is the ion. And whenever it comes to writing the formula, we put the ion in brackets and then we put whatever number afterwards. So that was the final part of writing chemical formula, National 5. Thank you for your attention.